Hey guys, Mike here. Welcome back to Extra Life Gaming. We're doing something a little bit different this time around. It's just me and doing a little solo episode here, and I want to talk about Universe Sandbox Squared, which is really fun universal physics simulation. It's on early access on Steam right now, and it allows you to basically play around with physics of planets and stars, and it's really cool. What we have here, of course, is our solar system. We have Venus, we have Earth, all represented. Here's Mars out here. But the solar system that I want to talk about is a little bit different from this one. And here it is. And it's the... at first it looks a little bit similar to ours because it's centered around a sun-like star just like ours. However, the arrangement of planets is a little bit different. So welcome to the FS-176 system from the Metroid series. This is actually a rather significant solar system in the Metroid games, in that it is not only the setting for two of the main Metroid games, the original Metroid and Super Metroid for the Super NES, but is also the setting of the first Metroid Prime game, and some fan speculations that it might also be the home system of the series heroine, Samus Aran, Space Bounty Hunter. And we're going to be talking about basically each of the different planets in the system. A lot of this information was actually gathered from the original Metroid Prime game, where if you go to the observatory in the Phendrana Drifts, you can find a holographic representation of the whole solar system, which shows all the planets in these very erratic, unusual orders, or unusual directions and orbital trajectories that's very unlike most other solar systems that we've found, and especially our own. And nonetheless, it looks... the effect of it is pretty cool, and I use basically very carefully looking at the angles and trajectories of that in the game in order to plot the angles and inclines of these orbits here. And we're going to start off with the farthest planet in this system, which is right here, Talon 4, which is also the planet on which the first Metroid Prime takes place. Let's just zoom into that world here. Here we go. Isn't that a beautiful little pearl in space? Yeah. So what we have here is a rather unusual planet, first off, in that unlike every other planet in the system that rotates counterclockwise around the star, or at least almost every star, or almost every planet here, Talon 4 is unusual in that it actually has a retrograde orbit. It orbits clockwise around the star, and its revolution is also the opposite. It's orbiting. You see, it's orbiting towards its west direction, whereas most planets orbit to the east. And there's some fan speculation as to why that might be the case. The most plausible explanation I've seen is that Talon 4 is actually what would be considered a captured rogue planet. Some of the in-game data files describe it as a wandering class planet, which isn't really any real astronomy term. It's also a little... it's a problematic classification just because even the word planet is derived from the Greek word aster planetes, which means wandering star, which was how the planets appeared from the night sky and on Earth, seemingly sort of wandering this way and that throughout the sky due to the fact that they were orbiting around our star at the same time that Earth was also orbiting. But rogue planets are a thing in that they are planets without a parent star, And in fact, the Metroid series has an example of one in the form of Aether from Metroid Prime 2, which is described in-game as a rogue planet and fits that description in that it does not orbit any star. But we won't be talking about that one specifically. We'll just be talking about this system. But that's the most plausible explanation, is that Talon 4 was originally a rogue planet that was just floating through interstellar space and then got caught in FS-176's gravitational field and happened to be going in a different direction than it, and therefore it wound up in an orbit that was completely different from all the other planets. Now we're going to talk a little bit about the specifics of the planet's properties. It's actually possibly one of the most Earth-like planets in the entire system, in that the environments you can explore in the game include like a surface jungle and icy plains, possibly at the poles, and as well as desert regions. And you see that the planet has a nice mixture of both desert regions and these darker patches that could be plant life. And right now, the temperature of the planet doesn't really reflect what it should be, and that's because the simulation just started. And, well, first of all, one of the other facts that we know about the planet is its distance from its star is described as something like 778 million kilometers, which is about 6 astronomical units, or about 6 times the distance that our planet Earth is from our sun. So Talon 4 is actually way out there, closer to the orbit of Jupiter, so it won't be receiving much sunlight, and that's reflected in the simulation right now in that its surface temperature is so low. But you'll notice it's gradually ticking upwards as the simulation progresses, and that's because, well, obviously the temperatures that we see in the game aren't below freezing. They're not below 0 degrees Celsius because there's liquid water and everything on the planet. So to compensate for that, we had to apply some greenhouse effect in order to increase the temperature to a more Earth-like comfortable range. And right now, the only effective way to do that in Universe Sandbox is to increase the atmospheric pressure. So here you see that it's listed as about 11.3 atmospheres, which means the surface atmospheric pressure on Talon 4 is about 11 times that of Earth, which actually is not so bad in that it's something that humans could theoretically survive on as long as you became acclimated to the pressure. At one point in the game, Samus actually takes her helmet off at the end of the game, and given that the average playtime of Metroid Prime is a couple hours to maybe no more than 20 hours, that would have given her suit more than enough time to acclimate her to the pressure of the atmosphere here, and she would be able to take off the helmet no problem as long as the planet has an oxygen atmosphere. It would only need to have a little bit less oxygen than Earth, because that's very high atmospheric pressures, oxygen actually becomes toxic in high enough concentrations. So likely Talon 4 has a lower oxygen content than Earth's atmosphere. And it's also worth noting that 11 atmospheres of pressure is actually not that unusual, in that compared to Venus in our solar system, which has, I think, something like 91 atmospheres of pressure. So Venus atmosphere is like a horribly thick soup compared to Earth's, and Talon 4's atmosphere would be very balmy and comfortable by comparison. So as you can see, the surface temperature is gradually rising to where it's supposed to be. I'm just going to go ahead and increase the simulation speed a little bit so that it gets to the right level. And after running it at a faster rate, we see that the temperature is balanced out around 6 degrees Celsius, which allows for liquid water in a very comfortable, relatively comfortable temperature. And because the orbit of this planet is relatively stable, I think the eccentricity is only 0.04. It's going to remain roughly equal throughout its entire revolution. And yeah, it's starting to look a lot better here. We see we got patches of ocean, small seas, and you can imagine that it freezes towards the poles. So Phendrana drifts might be somewhere up here. These large barren areas could be where the Chozo ruins are found. So, yeah, it's very nice, actually. Another point I wanted to address is that another statistic that's given in the Metroid Prime is the mass of the various planets, which are described a little bit odd. Talon 4 is listed as having a mass of something like 5.1 trillion teratons. The implication apparently being that it's supposed to be slightly less massive than the Earth, which it's possible that they actually made a mistake in the metrics there, because number one, teratons is not really a unit of measurement that's used for planets. When we're talking about the mass of celestial bodies, we usually prefer to list them as using kilograms and a scientific notation. So, for instance, the Earth has a mass of roughly 5.9 times 10 to the 24 kilograms, which is something like 5.9 sextillion tons, or no, 5.9 sextillion kilograms. There's really no reason to use the tons metric, because that's just 1,000 kilograms. You might as well just use kilograms metric. So they actually overestimated by quite a large margin the mass difference here. 5.1 trillion tons would actually put this more along the lines of 5.1 times 10 to the power of 26 kilograms, which is 2 larger than Earth, which means that if Talon 4 actually were at that mass, and it would not actually be able to maintain the same diameter that is shown here. It would actually balloon out to a tremendously large size. Let me just demonstrate that real quick by just changing the notation here to 26. And we see that the radius is increasing dramatically. We also see that the surface temperature is actually dropping somewhat. And that's possibly due to the atmosphere spreading out over a larger area. And the surface gravity is increased from slightly less than Earth's, which was originally around like 8 meters per second, whereas the surface gravity on Earth is about 9.8 meters per second. Here it's increased to 95 meters per second, which is absolutely crushing. So it's unlikely that this was the intended numbers. Let's turn it back to 5.1 and let's see if anything was messed up in the simulation. It doesn't look like anything was affected too badly, so that's good. Okay, yeah, and now Talon 4 is back to normal. So, basically for all the other planets, I assumed that they got the numbers off, more or less the same, and based them on this range instead, and it works out a lot better, in my opinion. So the planets fit more what the descriptions of them describe, if you assume that they are within Earth size for the most part, with one exception, which I will get to in a little bit. And moving on from Talon 4, we have the next planet in, which is called Twin Tabula. What's represented here is just a random planet that was generated, and I was trying to go for something that did not look at all Earth-like or whatnot, because the planet is described as relatively hostile to life. The visual actually for it in the data in the logs for Metroid Prime show a very different surface with a lot of small craters and lights on it, which I wasn't quite able to recreate in the simulation. There are some random planets that are created by the simulation that have bright spots on the surface, but that only stays if you pause the simulation from the start, that you create the planet. And I wanted the simulation to run for this solar system, so I was not able to recreate that. However, otherwise, the mass of the planet is relative to the numbers given, which, if we assume that they're, instead of being teratons, that they were meant to say gigatons, then Twin Tabula has a mass of 4.1 times 10 to the power of 24 kilograms. Again, much lighter than Earth, although it's shown here as having a higher surface gravity. And that appears to be due to the material content. It's a much denser planet. It has a very high iron content and in relatively little else. Very small amount of water, very small amount of organics. It's also the only planet other than Talon 4 to have no moons, which, number one, that's another candidate for Talon 4 being unusual in that it's an Earth-like planet without a moon, and it's possible that it had lost its moon at some point, either when it entered the FS-176 system as a rogue planet or through some other event. But Twin Tabula at least gets a pass in that it is definitely not capable of supporting life. However, its name comes from a disease that grows on the planet called the twin fever virus, which basically gives you a double vision as a symptom, and when that fades, the disease has entered its final stages, and the patient eventually dies. So there's some sort of life on this planet, although it's microbial at best, and that's even if you count viruses as a form of life. But it's probably typical of a lot of xenobiology in the universe, is that it's going to be a lot of single-cell life forms, and that all evidence shows that when the conditions on Earth became sustainable for life, that was the first form of life to exist almost immediately and continue to exist for billions of years. So the odds of finding single-celled life throughout the universe is much more higher than the odds of finding multicellular, more advanced life that we would recognize as like animals or plants or something else. So it's nice that they have an example of a just very uninhabitable planet that still has an interesting feature to it. Another thing I want to point out is that both Twin Tabula and the next two planets in have, as you can see, very, very unusual orbits to them relative to the rest of the solar system. They have these very elliptical and elongated orbits, and this is reflected in the observatory hologram. The result of this is that they actually vary their distance from the sun by like 1 to 2 astronomical units, depending on what point in their year they're at, and that's a tremendous amount for a rocky planet that's supposed to have a stable orbit in a solar system. The result is that most fan sites cite these planets as occupying either the second, third, or fourth position from the sun at any given time. With Twin Tabula right now being further out, it's going to come in much closer than the others eventually, but it gets out as far as the fourth planet years out in its orbit. And the next planet we're going to look at is further in, and it is Zebes, which of course is the home, the setting of both the first Metroid and the third, and for most of Samus's childhood is also her home planet, since after the space pirates destroyed her the K2L space colony, which we'll also be describing later, she was rescued by the Chozo, who are ancient alien race that had colonized many other planets in this system and possibly throughout the universe, and basically it was raised on this planet throughout her childhood and into her adulthood, during which she was infused with Chozo blood, which gave her various powers that the Chozo possessed, and also given the power suit, which she uses in her explorations and to fight space pirates and their leader, the Mother Brain, and etc. And despite early descriptions of the planet calling it extremely hostile and uninhabitable, it nonetheless has a very diverse biosphere, and is actually the second most Earth-like planet in this whole system. So the way I represented that was to give it a very slightly exaggerated orbit, such that the temperature varies by about 10 or 15 degrees throughout the year. Right now it's in the cold period where the temperature is below freezing, but if we just speed up the simulation for a bit and bring it around around the star, we will eventually get to its warmer period. Alright, now Zebes has entered its closest approach to the star, and is now warmed up to several degrees above Celsius, and so the ice patches have been melted into liquid water. This would represent Zebes as it appears during Super Metroid, where you not only had the liquid water area next to the wrecked ship on the surface, but it was also raining the characteristic acid rain that is described as falling for most periods of time on the planet. And this sort of periodic freezing and unfreezing could be an explanation for why the surface of the planet is almost completely barren, and most of the life exists under the surface. I also represented this by giving it mostly a silicate composition and very little iron relative to its size. And this is actually described in, I believe, one of the instruction manuals as the crust of the planet having almost a hollow texture to it, and having lots of subterranean caverns, which explains why you can go through areas like Brinstar, which is essentially an underground jungle, as well as Meridia, which is an underground ocean, and all sorts of other areas. And even areas like Meridia would probably remain liquid water throughout the year due to the internal heat generated in its mantle. And further down into it, you would get to the Norfair region, where you have a lot of magma flows and whatnot, and that would be sufficient energy to keep the interior heated throughout the year to a temperature that life would be able to sustain, possibly. It also fits with some depictions from the Metroid manga, where we see Samus without a spacesuit on the surface of Zebes with the sun visible in the sky, and that was probably during these periods of relative warmth, whereas she and the Chozo civilization that lives there probably retreated underground through the portal doors that exist on the surface, and probably lived for the most of the year underground, either during the cold periods or during one of the acid rainstorms. Incidentally, the entire concept of Brinstar is rather unusual in that the idea of an underground jungle seems counterintuitive, because there would be no sunlight for the plants to engage in photosynthesis. And one possibility, or one fan speculation, is that the plant life, quote-unquote, on Zebes actually undergoes some form of chemosynthesis instead of photosynthesis. And lastly, it's been described that the Chozo once had a planetary defense shield around Zebes, which was eventually destroyed by the space pirates using a micro black hole, which probably eventually led to the space pirates taking over planet Zebes and setting up their base, and using the Mother Brain as their new leader and turning her evil and stuff like that. So now we go from Zebes to the next planet inwards, which is Ormine 2, another planet that we only know from the observatory's hologram. And just like Twintabula is described as mostly uninhabited, although here it's described as having no life whatsoever, and instead considered a wasteland class planet, which is actually a phrase that's used during Metroid Prime as the possible fate of Talon 4. The entire plot of that game revolves around a meteor known as the Leviathan that crashes onto Talon 4 and brings with it the Phazon that spreads and corrupts the entire planet and eventually will destroy all life on it. And it would have left it a wasteland class planet. So Ore 2 is already that, and is described as being racked by nuclear dust storms and intense seismic upheavals. So there's not much to represent that in Universe Sandbox 2, although I did add this moon here, which, given the mass of Ore 2, is much lower than that of Earth's. It's only about 1/3 the mass of Earth. However, the moon here, which is named this is a random name that was given to it. All the moons in the system are unnamed in the games, so I just went with the random ones here. But this random moon happened to be about 2 times the mass of our moon, and I also put it in at a much closer distance to Ore 2. So the result is that tidal forces that Ore 2 experiences is significantly higher than that on Earth's. Let me see if I can find the effective here. Here it is. So the tidal stress magnitude is 0.00002, which, by comparison, Earth's tidal stress due to the moon is 0.00005. So Ore 2 is experiencing about 10 times the tidal forces that Earth would experience from its moon, meaning if there were any water on here, the tides would be much higher, and it's possible also that that would cause more earthquakes than normal, possibly due to the pull of this moon here on the surface would constantly be shifting and churning the crust and creating a lot more earthquakes than you might expect on the planet. Anyway, that's all there is really to say about Ore 2. So before we move into the innermost planet, I wanted to at least address this curious asteroid belt that is displayed in the observatory, but doesn't have any name or data log for it at all. My personal speculation is that it's actually the remains of the K2L colony, here just represented with a random asteroid that I made. But so as of now, there's no canon explanation as to exactly what happened to the K2L space colony. It's not even 100% canon that it's actually in the same star system. It's only described in the Metroid manual as being nearby Zebes. Of course, the planet SR388, where the Metroids, which is the Metroid homeworld, is also described as being nearby Zebes, and is never represented as in the solar system. So when the Metroid games describe any planet as nearby another, they could mean it's in the same solar system, or it could be in some other star system many light years away, and we're never quite sure until we actually see evidence of it. Nevertheless, I think there's a couple of reasons why this asteroid belt could count as the remains of the K2L space colony. The first is that it's never specified as to whether the K2L was a colony orbiting, was like a constructed space colony orbiting a planet, or if it was a settlement on a planet. I think it's most likely that it was a settlement on a planet, in which case it would have to be some sort of Earth-like planet with Earth-like conditions. And given the only distance that's given in this in this system is Talon 4's distance from the sun, I had to estimate the distance of everything else, which I put at anywhere from 2 to 5 or 2 to 4 astronomical units from the star. So that left this huge empty space for, to put everything else, because of course these 3 planets all orbit almost the same distance, just at really odd orbits from one another. But this asteroid belt, in the meantime, can actually be located very comfortably about 1 astronomical unit away from the star. And given it was if it was an Earth-like planet, this would put it right in the habitable zone and would have likely had Earth-like conditions. So it would have been a prime place for the space or the Galactic Federation to put a colony. And given that the observatory that we see is a space pirate observatory, it's likely that they wouldn't have any data on, or that they wouldn't have the same designations as the Galactic Federation for different planets and systems. So it's likely that they at some point had destroyed the K2L planet, possibly with the same micro black hole that was used to destroy the defenses on Zebes, and the remains is this asteroid belt here. I actually created this asteroid belt with about 0.8 the mass of Earth, since it's likely that some of the debris would have been blown out or sucked in by the black hole, and all that's left behind is this very sparse debris field. And like I said, this is 100% headcanon, but I like to think that even at a young age, Samus was escaping exploding planets, and I don't know, it just works for me. So, in my book, that's the explanation for that asteroid belt. And now we take it to the final inner planet in the solar system, Bilium, which I've actually taken a lot more liberties with this planet than with others. Oh wow, okay. Basically, not only is this planet closest in, but it also has a very unusual orbit. It's the only other planet other than Talon 4 to have a clockwise orbit. However, unlike Talon 4, it does not rotate clockwise, so it's still rotating counterclockwise as intended. And while it's given the same sort of mass description as the other planets, in this case, it's given a mass of 3.8 trillion teratons, which again would be way in excess of most terrestrial planets. However, the in-game graphic for it, when data mined from the Metroid Prime ROM, is described as gas giant. So I just thought, just this once, I'll use the mass numbers as intended, or as given, and so that's why, we see that the mass given is 3.8 times 10 to the power 26, which gives it a very comfortable mass of about 1/5 that of Jupiter. And given its proximity of less than an astronomical unit away from the Sun, that would actually make Bilium a hot Jupiter, which our planet hunting exercises have proven that hot Jupiters are actually relatively common throughout the galaxy. And with Jupiter or larger than Jupiter-sized planets being very, very close into their parent star. At first that was thought of being an unusual feature, but we found so many of them that we have to assume that it's more common than you think. And that's the reason why I put Bilium as a gas giant. The other reason is because its atmosphere is the other major feature that's described in the game, because according to the observatory, this planet is under quarantine due to meteorolus in the atmosphere, which is described as a global exterminator virus, which sounds like some bizarre weapon of mass destruction that possibly was used by either the space pirates or the Galactic Federation at some point during their conflicts in this system, and the result is that whatever life may have existed in the upper atmosphere of this planet is now completely wiped out, and the whole system is under quarantine, presumably by both the space pirates and the Galactic Federation. The planet is also described as having 3 moons, which I've added in here. And I haven't gone over many of the other moons as well, just because whatever moons are shown are never given any names. So again, these are all just random moons. But I forgot to mention that Zebes is also supposed to have 2 moons, which I've also added in. We'll take another look at them later on. But for now, this system actually is not quite what I had originally set it up as. Originally, all these orbits were relatively flat, but since I have set the simulation to run for several years by now, they've gotten a little out of balance, probably due to their gravity interacting together. So this is not a very stable arrangement. It would probably be better to space these moons out a little bit farther so they had a slightly more stable orbit. But it also could be because of the odd orbitabilium relative to the other planets and the star that have been throwing this off course. In fact, all of these planets are in such a haphazard orbit that I find it hard to imagine that this system would actually remain stable over a course of millions or even billions of years. And another fan theory of that dates back to the K2L destruction, is that given that the space pirates are described as being able to use micro black holes as weapons, which they've used at least once already in the system in order to destroy the defense field on Zebes. So, if not once, why not a second time? And it's possible that creating 2 black holes, even if they're somehow contained later in the system, was enough to throw off the orbits of all these planets. So maybe they weren't originally like this, but due to the conflicts between the Chozo and the Galactic Federation and the Space Pirates, they've all been thrown out of alignment like that, and it's quite possible that this solar system is not long for this world, or this galaxy, as it were. Because who knows if eventually Zebes and Twin Tabula could interact with their gravity too much that one of them gets thrown out into a farther orbit or even ejected from the solar system. Now, I wanted to go back to a couple of planets in here, Talon 4 and Zebes. We're going to start with Talon 4. So here's a new simulation with just Talon 4 in orbit. And in fact, I've set it up in a regular orbit going clockwise with a similar rotation period. And the reason for that is because one of the fan theories is that Talon 4 might have originally had a normal rotation and revolution period, but the impact of the Leviathan, which was the living meteor that carried the Phazon corruption, might have altered the orbit and revolution of the planet. And I basically set up this simulation just to show how that's incredibly unlikely, given that, well, basically the amount of energy that it would take to actually alter the orbit and the rotation of this planet is so incredibly massive that it would likely just completely destroy the planet before actually doing anything to its velocity. And to demonstrate that, I'm going to slow this down a little bit more and just start off by launching what could be a stand-in for the Leviathan. So let's just launch Halley's Comet at Talon 4, and let's even try to angle it a little bit so that we're hitting it about here so that it can potentially get flung off course. And now we just gotta wait for it to travel and impact. Here it comes. It's going at about 10 kilometers per second. And we have impact. So right away we see that the the devastation of the Leviathan makes sense in that impact alone sent out so many other fragments around that the planet would probably have seen multiple impacts throughout the whole system. And you see it left behind a visible scar. Now, what's not shown here is the potential atmospheric disturbances, like kicking up dust clouds and stuff. Halley's Comet is actually significantly smaller than the asteroid that's theorized to have killed off the dinosaurs in the K2 impact 65 million years ago on Earth. But even then, if it would have only been about 10 kilometers across, meaning it would have a radius double that of Halley's Comet and a mass significantly higher. But even if we launch Halley's Comet again at a higher velocity, let's say 30 kilometers, it's still not going to create much of a difference, as you can see. Like, we still have a very visible impact. It's very, very slightly larger, perhaps. But otherwise, you'll see that despite all those fragments flying out, the planet hasn't been affected one bit. Its orbital period is still the same. Its rotation is still 1 day, as I had originally set it. I don't even think it's been slowed down at all. However, the impact itself would have definitely caused a lot of environmental damage alone, on top of whatever poisonous or toxic attributes of the Phazon would have had. So it's possible that even if the Leviathan didn't contain any Phazon, that Talon 4 would still be seeing some trouble for hundreds of thousands of years just from the impact alone. However, let's imagine instead that the Leviathan was traveling at a significantly higher velocity. Since these asteroids or these meteors are sent out by the planet phase as a way for the life forms on there to reproduce. And they basically send these meteors out throughout the universe in order to plant themselves on other planets. And while the game hand waves this by saying that they can create their own wormholes in order to essentially leap around wherever they want in space, let's instead imagine that they are just traveling at an incredibly high velocity, since even if they had some magic wormhole technology that just let them appear wherever they wanted, they would still have to be traveling at a significant percentage of the speed of light to make any sort of progress throughout the universe. So let's say that they came in as fast as they possibly could at about 0.99% speed of light. And let's launch Halley's Comet again. Let's make sure we're lined up correct. And then see what happens. So even at this incredibly slow speed, we saw that debris fly off at near the speed of light. And so far it doesn't look like anything has changed. However, let's speed things up a little bit to less than milliseconds. Speed up to close to a second, a little bit more. And we see that the impact is expanding tremendously. Oh, jeez. Talon 4, what happened? So, yeah, this is what happens when Halley's Comet hits at near the speed of light. You get a way bigger result. Look at the surface temperature of Talon 4 is already exceeded 6,000 degrees. By comparison, the sun is less than that. It's only 5,000 degrees. So right now Talon 4 is glowing brighter than the sun. And if even the life forms that are capable of living in the Magmor caverns would be utterly annihilated by these temperatures. So this would effectively be a permanent total extinction event on this planet that would just leave it devoid of life for possibly forever. Like, it's hard to imagine that there would be any complex molecules left on here afterwards. Like, all the water would have boiled away and all the organic molecules would have broken down. So this is pretty much it for life on Talon 4. And we'll just adjust the temperature back to cooler one. And yeah, we see that there's no water left. Everything would have been wiped clean. And it doesn't actually represent the atmosphere being stripped away, but likely the atmosphere would also have been stripped away. So let's just take that off, and this is what we're likely left with, just a barren rock. However, if we zoom back out, we notice the trajectory still hasn't changed. It's certainly not orbiting in the opposite direction, and the rotation period is still the same. So there might be some limitations to the simulation here, and that maybe it would be possible to somehow reverse the rotation at least, but it's hard to imagine that a single impact would be able to do that wouldn't just tear the planet apart in the process. The only example I can think of in real life where a planet's rotation period has changed is on Venus, where atmospheric drag may be the reason why not only does the planet rotate very slowly, but also rotates in the opposite direction to most other planets in the solar system, which clearly wasn't the case here with Talon 4. So this, I think, puts the nail in the coffin for the theory that Talon 4 had a normal rotation and revolution until the Leviathan, and we're probably thankful that the inhabitants of Phase do not use this method of procreation, as there'd be little that Samus could do about this. In fact, it's hard to imagine that even a silicon-based life form like the inhabitants of Phase are purported to be would be able to do much with a planet that's been heated to 6,000 degrees, because, well, even they would need complex organic molecules to survive, even if those molecules were silicon-based instead of carbon-based like ours. So, yeah. And the final simulation I want to go over, well, actually the second to last simulation, is the ultimate fate of Zebes at the end of Super Metroid, which of course ends in the total destruction of the planet, which, given what we know about the space pirates being capable of handling micro black holes, it's not hard to imagine that if they're handling that sort of energy, it would be sufficient to destroy a planet if it got out of control, which is exactly what happens when Samus kills Mother Brain and the entire Taurian base melts down. However, we can actually simulate what would happen if Zebes were to explode. Let's start off by changing this to about 10 minutes for every second, so that we actually see the process. Before I destroy Zebes for good, though, I want to at least show off the moons of Zebes, which again we're not given names, so these are just the random names. And it's described as having two moons, one large, about our moon size, and one much smaller. So here they are right here. Again, with the smaller moon having a rotational period opposite to the other. And now let's see what happens to not just the remains of Zebes, but also the moons when we blow up Zebes. So Mother Brain has been killed, Taurian base is melting down, and Samus has escaped from there. She's saved the animals, because of course you would save the animals, you're not a monster. And she's gotten to her ship, and now it's time to watch from space as the planet explodes. Go! Oh wait, you know what would help if I actually run the simulation? Whoa, okay! Nice. Very nice. So immediately the orbits of the moons just go off on their own, and depending on how these moons interact with the debris from Zebes, they might continue to orbit around the star as normal, or they might instead change their trajectory and fall inwards into the inner solar system. And right now it looks like they're both heading out ahead of the debris field. In other times that I've run the simulation, they actually were affected by the gravity of each of these fragments and were catapulted inwards to the star, either to fall into FS-176 or to be flung out into the outer solar system. But here it looks like they're ultimately destined to wander around the star along with the rest of this debris field. Which eventually might look something a little bit like this. And this would be the FS-176 system as it appears at the latest point in the Metroid timeline, which would be just after Metroid 4. When Zebes has been destroyed, here we have the remains of it here. And all that's left of it is an asteroid belt. And at which point, given the close proximity of some of these other planets, both Ormine and Twin Tabula, to the orbital plane of Zebes' remains, it's likely that over the next few decades to millennia, they would be pelted by debris and become even more uninhabitable than they already are. So, even long after the story of Samus and the space pirates is over, this system would likely still be seeing a lot of chaos into the known future. And that concludes my little run through of one of the most well-known solar systems from the Metroid series, and my little showcasing of Universe Sandbox Squared, which is actually the official name rather than 2. And thank you for watching, everybody. If you enjoyed this video, just be sure to like, comment, and subscribe for more content. Possibly more Universe Sandbox content if I can come up with something unique to showcase. This is the first thing that came to mind because I had a complete solar system to work with. But if you have any ideas or suggestions, just let me know. And if you have any suggestions for what you would like to see in the future, or how we present our content, also feel free to let us know. And hope that you enjoy, and if not, just give us some feedback. And so hope to see you next time. Adios.